Hello everybody! Today I can write equations of sequences explicitly and recursively using their formulas, and this is pretty much your practice day. So this is the worksheet that says something about practice with sequences. In fact, what does it say? It says recursive and explicit sequence practice. So let's talk about what you need to know. Let's start with your explicit formulas. These are given to you on your reference sheet. There's arithmetic, and there's geometric. Arithmetic, an equals a1 plus n minus 1 z. Geometric, an equals a1 r to the n minus 1. They are both given to you. They're on the reference sheet. You just need to know when to use which. Arithmetic is when you are adding a common difference. If you're subtracting, that's technically adding. You're adding a negative. And geometric is when you're multiplying. So if you're dividing, that's also technically multiplication. Now, recursive a1 equals an minus 1. So let's go through our song. Recursive is not given to you. It's not on the reference sheet. So we have a song to help us remember it. So let's go to Common Core Algebra 2 songs. We've got recursive. All right, so for recursive, you're literally just writing whatever A1 is. You're filling in A1 with what A1 is, and then you're telling me what you're doing to the previous term. An minus 1 means the previous term. So, first off, we have to determine if it's arithmetic or geometric, and it was a little bit more obvious on the first sheet. Now it's getting a little bit trickier. So to determine if this is arithmetic or geometric, this one is not as easy to determine just by looking at it. So what I'm going to do is I'm going to subtract. I'm going to divide. Whichever one, if they subtract to the same amount, then it's going to be arithmetic. If they divide to the same amount, it's going to be geometric. And you're always doing the second term divided by the first, the third term divided by the second, the fourth term divided by the third, the later term divided or subtracted by the previous. So I always like to start by checking for arithmetic. So 376.8 minus 329.6. Now I'm going to do the next subtraction. 424 minus 376.8. And I'm going to try 471.2 minus 424. Do they all subtract to the same amount? Yes. So it's arithmetic, and that's D. If it wasn't, they did not subtract to the same amount, then I would try divide. So it's arithmetic. So it's an equals a1 plus n minus 1z. For explicit, again, I'm going to do it both explicitly and recursively. So an equals a1 is 329.6. N minus 1 stays n minus 1. D is 47.2. Now it's fine to leave your answer like that, but often you'll see it distributed out. So an equals 329.6 plus 47.2n. minus 47.2. Combine 329.6 minus 47.2 is 282.4. So it becomes 47.2n plus 282.4. So that's your answer for explicit. This is also your answer. And these are both for explicit. Now if I want to do recursive A1 equals an equals an minus 1. A1 is 329.6. And then what am I doing to the previous term? Well, I'm adding 47.2. That's my recursive formula, and the purple and the blue are both explicit formulas, and that's what I do. And again, I knew it was arithmetic because I went to my calculator, I subtracted, they all subtracted to the same amount. That makes it arithmetic, and it makes the common difference, whatever that value was. Is there anything else that I'm asking here? I don't think so. No, it's not wanted. I'm not asking for any specific term. All right, so let's try the next example. Looking at it, I can't tell if it's arithmetic or geometric, so I'm going to go to my calculator. I'm going to subtract. I'm going to divide, see which one gives me the same value. So A2 minus A1 is 72. 307.2 minus 192. Oh, that's not the same. Let's just make sure. 491.52 minus 307.2. So it is not arithmetic because they did not all subtract to the same thing. So now I'm going to try dividing A2 divided by A1. Dividing A3 by A2. Dividing A4 by A3. Do they divide to the same thing? Yes. So it's geometric. And the common ratio is 1.6. So let's start with explicit. Explicit is given to you on your reference sheet. AN equals A1 R to the N minus 1. A1 is 120. R is 1.6 to the N minus 1. That's it. For arithmetic, we can distribute and combine like terms. I can't do anything with the geometric formula. I'm done. Recursive A1 equals AN equals AN minus 1. A1 is 120. What am I doing to the previous term? Well, I'm multiplying it by 1.6. So I am putting 1.6 times the AN minus 1. Again, a lot of students might want to put the times 1.6 afterwards. I mentioned that in the last video. That's fine. But usually when it's multiplication, you'll see it written in front. That's your recursive formula. That's it. So again, subtract. Divide. These all subtracted to 47.2, so it was arithmetic. These all divided to 1.6, so it's geometric. I write down the appropriate formula, and then for the recursive, it always, whether it's arithmetic or geometric, it always starts the same way, and then you're just telling me what you're doing to the previous term. I want you to try 3 and 4 on your own right now, so please pause. Try 3 and 4 on your own, and then unpause. All right, now that you tried 3 and 4 on your own, I will go over them. Is this arithmetic or geometric? I don't know. So I'm going to subtract, 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 divide, 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 see which one gives me the same amount. 4050 minus 5400, 37.5 minus 4050. I can already see that they're not giving me the same amount. So no, this is not arithmetic. So now I'm going to divide, divide, divide. Again, I'm always dividing the second term by the first, the later term by the previous term. 4050 divided by 5400, 37.5 divided by 4050. Is that going to give me 0.75? Yes, it does. 2278.125 divided by 37.5. They all divide to 0.75. That makes it geometric. And that makes R 0.75. So if you didn't get that far on your own, then why don't you pause it right now and try and finish it from here. Write me both an explicit and a recursive formula. If you were good up to this point, then we're just going to keep on going. So let's start with explicit. Because it's geometric, the geometric formula is a1 r to the n minus 1. a1 is 5400. r is 0.75 to the n minus 1. There's nothing more to do. That is your explicit formula. Recursive a1 equals an equals an minus 1. a1 is 5400. What am I doing to the previous term? I never leave enough space. I'm multiplying by 0.75. So it's 0.75 an minus 1. That's it. Number 4, is this arithmetic or geometric? I can't tell just by looking at it. So I'm going to subtract, 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 divide, divide, divide. Negative 997.05. Okay, let's subtract the next pair. 3211.1 minus 4208.15. Yep, looks good. 2214.05 minus 3211.1. So they subtract to the same thing, which makes it arithmetic. And it makes D negative 997.05. So let's start with explicit. This is given to you in your reference sheet. an equals a1 plus n minus 1 z. an equals 520520 plus n minus 1 times negative 997.05. So it's okay to leave your answer like that, but you might see it in your slope-intercept form, so you would distribute. Minus 997.05 n plus 997.05. That's going to give me an equals negative 997.05 n. And then when I combine like terms, 520520 plus 997.05. 6202.25. 6202.2. That's it. Again, the algebra gets a little messy with all the big numbers and decimals, but the procedure is pretty straightforward. Now, if I want to do it recursively, I think recursive is a lot easier. Recursive A1 equals AN equals AN minus 1. A1 is 5205.20. What am I doing to the previous term? I'm subtracting 997.05, and that is my recursive formula. All right, let's see what's next here. Same type of thing, same type of thing. All right, so now we're going to go back and forth between the two forms. Let me just see what the next thing says. Write each recursively, then write each explicitly. So, regardless of which direction I'm going, to write a sequence, I need A1 and either R or D, depending on if it's, a common ratio, geometric, or a common difference, arithmetic. But these are the two pieces of information that I need in order to write a sequence, whether it's recursively or explicitly. So this is giving me an explicit formula. Well, this looks, because it's exponential, this looks geometric. Now, instead of AN, it says FN. It's the same thing. So I'm just going to write it as AN because I feel more comfortable with that. So we're looking at AN equals A1 R to the n minus 1. So I need A1, and I need either R or D, depending on if it's arithmetic or geometric. So A1 is 16. R is a half. Now that I have that, if it wants me to write it recursively, recursive A1 equals AN equals AN minus 1. A1 is 16. The common ratio is R, so that means I'm multiplying by 1/2. That's my answer. No matter which direction I'm going, I need to find A1 and either R or D. Once I have them, I can write either explicit or recursive. Let's take a look at 9. Well, which form is this in? I see AN equals A1 plus N minus 1 Z. So, again, I need to write a sequence, whether it's explicit or recursive, A1 and R or D. So, A1 is 9. D is 3. Right, 9 looks like an A. So, if I want to write it recursively, recursive A1 equals AN equals AN minus 1. A1 is 9. The common difference is 3, which means I'm adding 3 to the previous term. There's my recursive formula. 10's got a little bit of a twist, so I'm just going to start you off on it. It's not in the AN equals A1 plus N minus 1D form. It's in your slope-intercept form. So I know that D, I know it's arithmetic because it's linear. I know that D is 4. I need A1. Well, the best way to get A1 is to just substitute 1 into the sequence formula. 4 minus 3 is 1. Now that I have A1 and D, I can write the recursive formula. So I'm just going to wait. I'll give you about 20 seconds. Let's see if you can write the recursive formula from here. Recursive A1 equals an equals an minus 1. An is 1. The common difference is 4. That means I'm adding 4 to the previous term. There's my recursive sequence. Now we're going to go in the other direction. I'm giving you the recursive. I want the explicit. Well, again, I need A1 and R or D in order to write either direction, arithmetic, geometric, explicit, recursive. These are the pieces of information that I need. So based on this, well, I have A1 is right there. And based on this, this is saying that I'm multiplying by -2, which means that R is -2, which means that it is geometric. Since I'm multiplying the previous term by something, that makes it geometric, and the common ratio is -2. So I want to write it explicitly, so I go to my reference sheet. Geometric is an equals a1 r to the n minus 1. A1 is 12. R is -2. And there's nothing more to do. Now, Fn minus 1, An minus 1, it's the same thing. So if it's easier for you, I feel like it's easier for me. I'm just going to rewrite this in sequence notation instead of function notation. I just feel like it's going to be a little bit easier. So to write the equation of a sequence, I need A1 and either R or D. You know what? I want you to try this one on your own. Just as a hint, you're going to have to determine if it's arithmetic or geometric, and then you're going to write the appropriate explicit formula. So you're going to either, if it's arithmetic, you're going to use an equals a1 plus n minus 1z. If it's geometric, you're going to use an equals a1 r to the n minus 1. So why don't you pause it, try number 13 on your own, and then unpause it. All right, now that you tried it on your own, because I'm adding 4 to the previous term, because I'm adding, that makes it arithmetic, and it makes the common difference 4. Now that I have A1 and D, again, it's arithmetic, so I'm using the arithmetic formula. An equals -1 plus n minus 1 times 4. That's sufficient, but I like to go a little bit further in case it's multiple choice and I don't see that there. An equals -1 plus 4n minus 4. An equals 4n minus 5. Either one of these is sufficient. All right, let's move on. What's the next type of question we have here? All right, the 5th term and the 8th term. So there are different ways to do this. I am going to show you the way that I do it. When you have 2 random terms, we have the 5th term, and then there's a 6th term, a 7th term, and an 8th term. Here's how I like to do it. I like to set it up exactly as I have it there. I'm going to list the terms that I have. It says that it's arithmetic, so I'm adding the common difference to get this value. I'm adding it again to get this value. I'm adding it again to get this value. So what do I see? I see 19 plus 3D equals 28. So kind of set it up with these blank spaces in between. For each blank space, if it's arithmetic, we're going to write plus d. So there's 3 terms in between 5 and 8, so it's going to be 3d. Add the 3d to the first given term to get the last given term. Do the algebra. D is 3. Again, to write the equation of a sequence, I need A1 and I need R or D. Now that I have D, I need A1. So what I like to do, and again, there's different ways to do this, is I like to kind of go backwards. If the common difference is 3, if I'm going backwards, if the fifth term is 19, then the fourth term is 3 less than that. And the third term is 3 less than that. And the second term is 3 less than that. And the first term is 3 less than that. So A1 is 7. D is 3. So I can write it both recursively and explicitly. I don't think I specified which one I want you to do. I'm just going to do them both. So let's start with explicit. Because it's arithmetic, an equals a1 plus n minus 1 z. A1 is 7. N minus 1 stays n minus 1. D is 3. Again, you know what? I'm just going to leave it like that. So that's my explicit answer. I don't feel the need to go further with it. Recursive. Recursive A1 equals AN equals AN minus 1. So A1 equals 7. I am adding 3 to the previous term. That's my recursive formula. So when they give you 2 random terms, kind of set them up with spaces apart. If it's arithmetic, put plus d for each missing term. From there, you can come up with this equation. You solve it for d, and then once you have d, you can kind of count backwards to get to a1. There are other ways to do it, but that's the way that I'm going to go with. Let's get to the geometric one now. The fourth term is 4. The sixth term is 36. And it says that it's geometric. So I'm not adding the common difference. I'm multiplying the common ratio. So I'm multiplying by r to get the fifth term. Then I'm multiplying that by r to get the sixth term. So for geometric, it's a little bit different. It's 4 times r equals 36. So it's 4r squared equals 36. So geometric, again, is exponential. If it's geometric, you're going to end up with an exponent of how many terms are in between. Whereas if it's arithmetic, then you're going to multiply by how many terms are in between. So I do the algebra. R is 3. Technically, we don't know if it's positive 3 or negative 3. I'm just going to make this a little bit simpler, I'm just going to make the assumption that it's positive 3. So now, if I go backwards, I would have to divide by 3 to get the previous term. So if I'm going backwards, 4 divided by 3 is 4 over 3. And let's get the calculator going for this one, because this is going to get a little nasty with the fractions. So again, because the common ratio is 3, when I'm going backwards, I'm going to divide by 3. Now to go backwards, I'm going to divide that by 3. And then I'm going to take that and I'm going to divide that by 3. So the first term is 4 over 27. R is 3. I want you to now pause it and write the formula both explicitly and recursively, and then unpause. Okay, now that you've finished the problem on your own, let's do explicit first. All right, so my explicit for geometric is a1 r to the n minus 1. a1 is 4 over 27. r is 3 to the n minus 1. Done. It's bothering me. It froze in the middle, so I got a little flustered. I want to make sure my an is in there. So for explicit, all right, now for recursive, a1 equals an equals an minus 1. a1, 4 over 27. What am I doing to the previous term? Multiplying it by 3. That's it. All right, what else do I got for you here? Just some random questions. And then, ooh, okay. All right. I'll go over 19. No, I'll go over 20. The 8th and 10th term of a sequence are 64 and 100. If the sequence is either arithmetic or geometric, the 9th term cannot be. So this is a tricky question. I encourage you to pause it and try it on your own first. However, if you feel like you're lost getting started, then, don't. But basically, you're going to have to go through each choice and see if it works. So again, I would like you to try it on your own first, but if you feel like you don't know how to get started, then that's fine. All right, so at this point, if you wanted to try it on your own first, you tried on your own first already. I'm going to go through each choice. Negative 82. Well, first off, if it's negative 82, then it's going positive, negative, positive, which means it would have to be geometric. The only way for it to alternate signs is to multiply by a negative. So let's see if there's a common ratio. I'm going to do negative 82 divided by 64. I'm going to do 100 divided by negative 82. Is that a common ratio? Do they divide to the same amount? No. Can't be arithmetic because, again, they're alternating signs. It's not geometric, so that can't be correct. I'm going to go through all the choices. Let's try negative 80 now. Now, again, if it's negative, it means it's alternating signs, so it would have to be geometric. I can't alternate signs back and forth for arithmetic. So negative 80 divided by 64. 100 divided by negative 80. Do they have a common ratio? Yes. The common ratio would be negative 1.25. So yes, that could be the middle term. So that one works. Choice 3, positive 80. Oh, this thing is really starting to freeze on me. Really starting to freeze. So positive 80. Well, I kind of just did that. Let's try because it just worked for me geometrically, I can just do it again. It's just positive this time, so 80 divided by 64 and 100 divided by 80. They both divide to 1.25, so that one checks out. And finally, 82. Well, I know geometrically the middle term would have to be 80, so let's try arithmetically. Let's subtract 82 minus 64. Let's subtract 100 minus 82. And they both subtract to 18, which would make it arithmetic with a common difference of 18. So the only one that does not work would be choice 1. So it's definitely, I think this is a tricky problem. You have to just set it up like we set the other ones up with missing in between terms, and then just go through each choice and subtract, 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 divide, divide, divide. to see which ones have a common difference or ratio and which ones don't. The last set of problems are a little tricky as a teacher because you have to just kind of be creative, and it's hard for me to exactly teach you to be creative. I can't just say follow this procedure because, it's just not that simple. So your first thought should be subtract, 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 divide, divide, divide. 8 minus 3, 23 minus 8, 68 minus 23. They do not subtract to the same thing, so I try divide, divide, divide. And they don't divide to the same thing either. Which means it's neither it's neither arithmetic nor geometric. So first of all, the only way I can write this is recursively because explicitly it has to be arithmetic or geometric. This one is not arithmetic or geometric because there is no common difference, there is no common ratio. So you have to kind of be clever and figure it out. It's going to probably be a combination of multiplication or multiplication, division, and addition, subtraction. So I'm going to start by multiplying by 2. I'm just kind of guessing. I'm going to start, 1 doesn't count because I multiply something by 1, then I'm not doing anything to it. I'm going to start by multiplying by 2 and seeing what I have to do to get to the next number, and then see if that same rule works for the next one. So if I multiply 3 by 2, I'm going to get 6. What would I then have to do to get to 8? I would have to add 2. So if I multiply this by 2, then I have to add 2 to get the next one. So let's try that same rule. If I multiply 8 by 2 and then I add 2, do I get 23? Well, 8 and 2 is 16, plus 2 is not 23, so no, that didn't work. So multiplying by 2 is not going to work. Let's now try multiplying by 3. If I multiply 3 by 3, I get 9. What would I then have to do to get 8? I would have to subtract 1. So multiplying by 3 and then subtracting 1 is how I got from 3 to 8. So let's try that for the next one. If I multiply 8 by 3 and subtract 1, well, that's 24 minus 1, which is 23. Hey, it worked! Let's see if it works for the next one. If I multiply 23 by 3, I get 69, and I subtract 1, I get 68. I got it. So this is my rule. I'm multiplying by 3 and then subtracting 1. Now, how do I write that? Well, it has to be recursive. So recursive A1 equals an equals an minus 1. A1 is 3. And now what's the pattern? What's the rule? I'm multiplying the previous term by 3 and then subtracting 1. So I'm multiplying the previous term by 3 and then subtracting 1, and that would be my recursive formula. So listen, I really cannot give you a super procedural way to do this other than start by multiplying 2 and see what happens and see if that works, and then try 3, and then try 4, and go from there. It's possible you might be squaring something instead of multiplying it. I can't give you a super procedural way to always get these. They're challenging. It doesn't come up much, but it has come up in the regions once or twice. So, you just have to try different things until you find one that works. All right. So, number 22. They're getting smaller. So, well, again, you would subtract, 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 divide, divide, divide. I'm going to save you some time and say that that's not going to work. Neither of them are going to work. It's not going to be arithmetic or geometric. So since they're getting smaller, I'm not going to multiply. I'm going to divide. So I'm going to start by dividing 100 by 2, and I get 50. What would I then have to do to 50 to get to 60? I'd have to add 10. So I'm dividing by 2, and then I'm adding 10. So let's see the next one if that works. If I divide 60 by 2 and get 30, and then add 10, I get 40. It worked! Let's see if that same rule gets me from 40 to 30. Take 40 divided by 2, add 10. It worked! So that's my rule. I'm dividing by 2, and then I'm adding 10. I want you, now that we've determined that, I want you to write the recursive formula based on that rule. I'll give you about 15, 20 seconds. All right. Recursive A1 equals AN equals AN minus 1. A1 is 100. I am dividing the previous term by 2, and then I am adding 10. You could have written times 1/2 instead of divided by 2. Either way is fine. And that's it. There's a couple more examples of that here. Well, just one more example. This was one that was on the Regents. And that's it. So I know this was a lot. We're spending the entire block on this. It's just really important to get comfortable with sequences in general. So let's just recap what we did. To determine if it's arithmetic or geometric, subtract, 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 divide, divide, divide. In this one, they all subtracted to 47.2. In this one, they all divided to 1.6. If they all subtract to the same thing, then it's arithmetic. If they all divide to the same thing, then it's geometric. Explicit formulas are on your reference sheet. Recursive is always A1 equals, AN equals AN minus 1, and you're just telling me what you're doing to the previous term. To write, in general, if I want to write a sequence, whether it's explicit or recursive, arithmetic or geometric, I need A1 and either R or D. So if they give you, in this case, the explicit form, and they want you to write it recursively, you need to pull the A1 and the R or D from the formula to write the other, and vice versa. That was his next section. The next section, when you have missing random terms, set it up with little spaces in between. If it's arithmetic, you are adding the common difference however many times you have missing terms. So it's going to be the term you have plus the number of terms times d equals the next term you have. Whereas if it's geometric, you're multiplying, so it's going to be the term that you have times the common ratio to whatever power of the missing terms gives you the last one. Once you have the common ratio, the common difference, you have to go backwards to get to A1. And of course, once you have A1 and R or D, you can write the equation. Number 20, it's a little tricky. You just kind of go through each choice and see which one works. And then if it's neither arithmetic nor geometric, it'll be a combination of them. You're going to have to kind of just start by multiplying 2 and then seeing what you have to do from there and seeing if that pattern works for the rest of them, and keep on trying numbers until it does. And if that is the case where it's not arithmetic nor geometric, you can't write it explicitly. You're going to have to write it recursively, again, because explicit only works for arithmetic or geometric. Something like this is neither arithmetic nor geometric. Be productive, practice this, and have a great day.